Welcome to Talking Tuesday. I am your host, Fancy Quant, and today I am really excited to bring on our guest, Andreas Rossi. So, again, I am not Italian, I do not speak Italian, but Andreas does. I attempt to pronounce his name as accurately as possible here. But he is coming onto the channel for a variety of reasons. One of these being he has been a long time subscriber of the channel, and I have had kind of the opportunity to kind of help him along, give him information, and then let him make life decisions. And it's been actually really rewarding from my perspective to see him grow as a person. So he's really evolved and changed. So he was an undergraduate when I met him. He found my YouTube channel. We have interacted over the years. And then he had this really challenging decision, which many of you are facing if you are still in school, which is what degree do you get? Which profession do you pursue? Do you do quantitative finance, actuarial science, or data science? These are all three very solid careers, very popular at the time. And trying to figure this out. And so I've guided him and provided, just a lot of information about the industry and different perspectives for him to think about. And of course, he went on and made his own decisions, and I think he's done an amazing job at that. He has recently graduated and has started his first job as an actuary. Overall, though, I am extremely proud of him. I'm amazed to see his progress, and I will take a little note here for many of you. This is his first English conversation. So besides the fact that he has gone through and taken advice from me, and he's made great decisions, and it looks like he's really shaping up a solid career for himself, and it's great to see when people succeed. At the same time, I am just absolutely amazed that he can basically teach himself English from YouTube. Again, he mentioned he took a few classes when he was younger, but again, being able to actually teach himself English to the point of having a first conversation that is as good as this conversation goes. So, I don't know. I'm really proud of him. I think he's done an amazing job. I think many of you will enjoy this interview because many of you are from Europe as well. Many of you are just students in general with similar backgrounds trying to kind of discover which routes to take. And of course, in this interview, we have things we agree on and disagree on, but I hope you guys have a good takeaway of the different perspectives. Without any further ado, let's dive on in. So welcome to Talking Tuesday. I am your host, Fancy Quant, and today we're going to welcome our guest, Andres.
Yeah, thank you, Dimitri. Thank you for having me.
So why don't you just kick off here and give everybody a quick introduction of kind of who you are, what country you're from, because you're a little different than my typical American guest.
Yeah, sure. Okay, I'm from Italy, so all my perspectives I will give are just based on a European point of view. I am an actuary now. I started working this week. I'm working for PwC, and I hold a master's degree in financial engineering with actuarial concentration. So this is basically what I am, what I do.
Okay.
And yeah.
So why don't you tell us how you even found quantitative finance? This is kind of a weird topic that all of us don't really know a lot about.
Yeah, I think even my answer will be very weird in the sense that I found quantitative finance like actuarial science the same way. It's like an interesting topic. It's like applying science, it's applying hard science to finance. Don't know what to say really about it. Just find it interesting, and that's why I know your channel. So just sorry for not giving a very good insight of my opinion of quant finance.
It's okay.
It's just cool. It's just cool. It's just cool. Yeah.
So for a lot of the listeners who don't know, or if they don't recognize your name, your comments are up quite a bit on my YouTube channels. And I don't know if you know this, but next to your name, I see a heart, which I don't know if you see it because.
No, I don't know.
Okay.
No, I can't. I don't see that.
Okay, you have a special badge actually that YouTube gives you. And when I put my mouse over it, it says, this is someone who has the most comments that are liked by you.
Oh,
so I didn't know that. But
you're so dear.
But we go back a long ways. I think it's at least, 4 years? Something around there. You've been part of the channel for a long time.
Yeah, it's been since 2017.
Oh, wow.
I found your channel because I was looking for a master's degree. But as I went to Google, internet, and just I've seen around about those kind of jobs, and I was looking for actuarial jobs. I found like the quantitative analyst, and I've seen that like, oh, that's cool. Like finance degree, financial engineering degree, you need stats. What is that? Let's see something around that. And just finding on YouTube, just your channel was the first option. And I just started looking at your videos. And that's how I found you. And that was, 4 years ago already.
Okay. So because we've been talking a lot. And I remember, so you've grown a lot. I remember some of our first discussions, but I remember one of the big ones I think a lot of students have, which is, what degree do I get? Because it's so exciting. And it's like, you want to do quantitative finance. There's also statistics. Then there's actuarial sciences. And now we have data science, machine learning coming on the scene.
Yeah.
And I remember you were stuck between like, what do I do? Do I get the data science degree?
Yeah, exactly. Yeah, I was like annoying you a lot about that. I remember that. Like, what do you think about that? What do you think about this free elective? Do you like more like GLM? Do you prefer data analytics? Whatever. I was like annoying you for many months. and I ended up with actuarial science at the end. But I found your channel just because of that. Like, what is a quant?
So what was your undergrad in? Your undergraduate degree?
Economics and business.
Okay.
So that's my undergrad. And I didn't really like that. I didn't enjoy that. And the reason is you do a lot of theoretical stuff. You don't do math, you don't do stats. And I have always been just so good at math since the high school. I mean, since when I was at primary school, actually. But I always enjoyed doing math. And I said, okay, economics is not for me. I just don't like accounting. I don't like just management or stuff like that. I really want to go very deep into something which is much more technical. I'm quite good at programming. I'm quite good at stats, maths. I had statistics. So at the end of the day, I thought, why should I go with economics in my master's degree? I didn't really like that. I don't remember anything of what I've studied. It's like I just studied a lot of useless stuff. I never used them in my life. I really want to go to something which is technical and a lot of, above all, useful. So I thought that maybe quant finance or statistics was something more just made for me.
Okay. And so how did you finally make that really tough decision? Because I know, looking at it, even from my perspective, as someone who's already gone through my decisioning of, how did you end up selecting financial engineering with actuary specialty?
Okay. In actual fact, financial engineering and actuarial science were very, very similar to each other. But the main reason is just the problems and challenges of finding a job in Italy. Mm-hmm. So I knew that quant finance and actuarial science, they both have a lot of promising things. But when I was looking for jobs at the end of the day, I found that there were very few quant jobs, actually. There were very few, and in Italy, the quant profession is known, but it's at the same time not really clear. Like you may find a quant job with a different title, and you don't know that. Just to make an example, I had an interview last month as a front office quant for the trading part, but the title of the job was like portfolio data analyst, which doesn't make sense at all. So if you see that portfolio data analyst, you just think, okay, it's not a quant position, it's something else. Why should I just look at that? And I was just reading, okay, you need time series forecasting, you need machine learning, you need programming. Okay, this is a quant position. so okay, I apply for that. And at the end of the day, I just decided to go into actuarial science because I didn't know that. So finding a quant job is more difficult here. Maybe you can find positions like statistician, econometrist, data analyst, but data analyst can mean everything. You can be a business analyst, or you can be the hardest quant in the world, but you could be anything. I didn't know that, and I've seen instead that actuarial science was a very safe option because actuary was a very traditional profession. And I don't know if you have in the United States. In Italy, we have like a statistics site of degrees where for each kind of degree, each class of degree has a rate of employment, uh, average salary, so all those things for every single degree. And just looking at all the possibilities, there is only one master's degree with 100% employment rate, and that was actuarial science. So I said, okay, that's my profession. I'm gonna be an actuary. Let's go. That's how I found
that's how you
the
found
job.
it.
Yeah, and also with one of the highest salaries as well.
Okay.
So yeah, but in actual fact, actuaries and quants are almost the same in terms of salaries here. But
Okay.
I guess in the world, it's like the same, about the same.
So it varies a lot in the US, but we have similar problems. So the problem you have, like when you go online and you search like, I don't know, quant analyst, you'll find a few jobs and some of them aren't quants. And then you'll find other jobs where it's like, you're like portfolio analyst and you're like, kind of sounds like a business job. And then you're right, you're reading through it and you're like, oh, this is an actual quant job.
Yeah, exactly.
And then it gets worse because, so I work in credit risk a lot of times, and there are credit analysts, which are business people. And then you have credit model developers, which are quants.
Yeah, it's quants, yeah.
And so we have that same, like, there's no way to find it, which is part of the issue. We don't have any sort of, so it's a very European idea to have like pay grades and have all that information.
Yeah.
And I remember on Andre Kratz data plumbing YouTube channel, he has one on data engineering, and he talks about on there how much data engineers actually make, and he starts going through like these pay codes, which is like completely foreign to the US, because you could, like, I don't know, you could have two people that are both the same job, same role, two different firms. And the one firm can say, I'm going to pay you $60,000. And the other firm could say, I'm going to pay you $250,000. And you could be doing the same job and have very difference in pay.
Yeah.
So it's really hard in the US to even compare, where Europe's a little more structured in how the pay schedules get put together.
Well, I'm not sure if it's more structured, but yeah, it's at least it's even easier to understand what kind of job or profession are you going to do, and just to understand what's your employment rate, because you have those statistics which are public. So basically that's the reason I've chosen actuarial science. Yeah, I found that being even interesting as profession, because it just encompasses a lot of things. You use a lot of mathematics, statistics, like there is a huge overlapping between actuaries and quants as well. So I found that be very interesting, but at the same time, like 90% of my decision was because of that 100% employment rate. Actuaries are extremely needed here in Italy.
Okay.
It's not like in the United States, you have like, I don't know how many, probably like 50, 60,000 actuaries. Here in Italy, we are like about 1,000, no more.
Wow.
Yeah, we are very few. They pay you like with everything they have. Like, please come to work with me. Like, I give you my house, my wife, I give you everything, I give you my life. It's like that. It's like that. And the
Okay.
first day I went to PwC this week, like one of the PwC partners came to my desk and he said me, "Hey, do you know someone uh, who's skilled, who's good, who has studied with you? Because we need more actuaries here. Just we don't have so many." So yeah, actually is an extremely let's say it's just one of the most paid and
Yeah.
safest professions here. Being
I
an actor is even better than being a doctor or a politician. It's like, so that's why I wanted to be an actor.
Okay, that makes a lot of sense, and I'm actually glad you made that decision.
Yeah.
Because I try to explain on the channel a lot about trying to explain to people 70% of all quant jobs are in the US, and then another big percentage is in the UK. And so when you
Yeah.
start
Exactly.
going to even other countries that are developed like Italy, there's not a lot of opportunities. And even when you start going, so a lot of my subscribers actually come from other countries that are considered third world countries. There's no structured finance system there. And then on top
Yeah.
of that, right, there's no way to even have a quant job. And so I think looking for jobs like being an actuary is very similar, but it's been around for so long that there's a well established
Yeah.
like system in
Exactly.
place.
Yeah. It's like saying the lawyer.
Yeah.
It's not a known profession. I guess even in United States, if someone asks you, okay, what's your job, and you say actuary, they say, what, actor? So yeah, maybe. Also, but yeah, it's a very unknown profession, but at the same time it's an established profession, so like the lawyer, like the doctor, the engineer, so it's a very safe one.
Okay.
So
Yeah. That makes a lot of sense.
yeah. Yeah.
So do you want to talk a little bit about, so we had an interesting conversation, oh man, a couple of years ago on, so about mathematics, probability, statistics, actuaries. One of our
Yeah.
interesting points was that probability is found in math departments.
Oh yeah,
and,
yeah. I remember that. I remember
and
that. I
statistics is
remember
found in
that.
its own department. And so I just figured we'd talk a little bit about, so actuarial sciences is in the math department, correct?
No, that's what I wanted to point out.
Okay.
Yeah, actuarial science is in math department in United States. In
Mm-hmm.
Europe, it comes from the statistics department,
Okay.
and there is a good reason behind that. And I think the reason is that like 50% of actuarial profession is all statistics, while on the other 50% is like financial mathematics, actuarial mathematics, stuff like that. But it depends on what kind of actuary you are. So if you are a life insurance actuary, which in United States you call long-term actuarial science, you are working a lot with financial mathematics. So yeah, you could say you are a mathematician, maybe. But if you are a short-term actuary, so a non-life insurance, which is also known as general insurance,
Mm-hmm.
you are working completely differently. You are like very similar to a quant. So you are using a lot of statistics just to make the pricing and the reserving. So it's a completely different approach. In life insurance, you have even an interest rate because you have to discount the future amounts. Yeah.
It's
In
like
short
traditional
term,
finance.
Yeah, exactly. It's something like traditional finance. It's all about financial mathematics and actuarial mathematics. The only difference is that you are using actuarial tables, you are estimating probabilities of people dying, people surviving. On the other hand, if you are in non-life insurance, you are basically an insurance quant, let's say like that. I think I see an actuary like an insurance quant, and I see quants like banking actuaries. Actually, yeah, something like that. But yeah, it's completely different. In non-life insurance, you are a statistician. In life insurance, you are more a mathematician.
Okay.
But yeah, whatever your specialization is, during your education, you must have a strong statistical background. I mean, you must go into probability theory, statistical inference. You must know just time series modeling. You must know multivariable statistics and all those things. Those are just common backgrounds for whatever you are meant to do.
Okay.
Even if you want to be a quant, you still have to know all those things.
Yeah.
And one difference between actuarial science and just quant finance I wanted to point out is that let's say you have this huge background in common. You have like 80% of background in common. So you have stats, you have maths, probability, you have programming, you have time series, econometrics, all those things. The only crucial difference is that actuaries are then going into actuarial mathematics, which is designed specifically for insurance.
Mm-hmm.
So short-term and long-term actuarial mathematics, which we call life insurance and non-life insurance in Europe. While on the other hand, quants are going into stochastic calculus. That's the main difference. Stochastic calculus versus actuarial mathematics. But for the rest, I think you are going to face the same things, same stuff.
Yeah.
And even master's degrees. My master's degree is a financial engineering degree, but I had an actuarial specialization. But at the same time, my master's degree offers just a quant finance specialization. And we had 8 subjects in common.
Okay.
And 4 subjects which were the specialization. So I had like 4 actuarial mathematics classes, and on the quant finance they had 4 time series and stochastic calculus classes. But for the rest, it was the same probability class, statistics class,
Mm-hmm.
econometrics class. So, and that's another thing I wanted to point out also. This is the reason because an actuary can do a quant job, and because a quant can be an actuary as well. In my opinion, in my personal opinion, it's not so hard to switch between them because you basically have the same background. You just went deeper into stochastic calculus or actuarial mathematics. But
Yeah.
I mean, even a quant, even if you want, you just study by yourself a little bit of actuarial mathematics, and you can just be an actuary. Just as simply as it is. Yeah, as simple as it is.
Yeah. I think so. This is the hardest question I've been asked because I made a video,
Yeah.
I believe, I don't know how many years ago, a long time ago.
Yeah, quant versus actuary. I remember it.
Yeah.
Yeah.
And
I remember.
It's so hard to answer from a couple perspectives because the first point is like you're pointing out, right? The skills are so overlapped.
Yeah.
You can do both, but you have to get in at the entry level so you can get the training to go up. And one of my colleagues actually had an actuarial master's. So he went like kind of cute. He had like actuarial specialization, and then he decided I'll go work in quant finance, so the skills lab.
Yeah.
But I think the biggest hurdle between the two, it's changing the mindset of what you're modeling. I mean, it's all data, right? You're modeling short-term, long-term insurance products.
Yeah, correct.
Where quants are modeling the finance side. And I think one of the big hurdles is just trying to switch kind of the business logic of what you're working in.
Yeah, true. That's true. True.
Yeah.
But yeah, I don't think it just takes so much. Probably it would, but I'm not sure it's so hard to do.
Yeah, it's possible. It's definitely a
Yeah, it's
possible route.
possible. Yeah, it's possible. At the end of the day, if you think about it, how to be a quant, you need at least a master's in some technical stuff. You can be a master's in physics,
Yeah.
right? But yeah, if you come from a master's in physics, and if I come from a master's in actuarial science, which may be closer to the master's to quant finance, right?
Yeah.
They are almost the same. So, I mean, my master's in actual fact is quant finance master's, but I just did a little bit more of actuarial mathematics. That's the only difference. And just to show how similar they are, at the moment I am working for a project for the government, and we are a team of 4 actuaries, and we are in collaboration with a team of 4 quants.
Okay.
So we are basically 2 teams, one actuarial team and a quant team, and we are just working together. So that's why I wanted to ask you, do you think actuaries, quants, data scientists are going to merge in the future?
So,
and if yes, why? And if no, why?
Okay, this is a tough one. I'll offend a lot of people with this response. There was a statement made by a famous quant in Europe, of course, about how quants are nothing more than a subsidiary of actuaries.
No, I don't think so.
So he views it, and I get a lot of questions, and then they'll reference him. They actually link his comments. But I think, at least from a United States perspective and from a global perspective, you'll continue to see almost all quants in very, very concentrated areas. So like the United States, you can look at quants, if you could count them all out, the majority are going to sit in New York and Chicago.
Okay.
And then if you go to Europe, it's going to be in London, and I'm guessing it'd be in Munich and in Germany, because
in Germany.
Yeah, they're financial hubs.
In Frankfurt. Yeah. Frankfurt and Berlin.
And so I think as we see kind of a shift, I think they'll remain separate. And I think one of the problems I have a lot with working with actuaries, I've interviewed a handful of them and chatted with them. They always like to think they already know everything a quant does, plus they have something else.
No, that's not like that. That's not like that.
Yeah, and I've met a few good actuaries, like my old colleague I used to work with. But I think it's to the point that you're making, though, right? The difference between the two is going to be the specialization. And I don't see the specializations ever merging where you would see, like, even if a bank had like an insurance division and then they had like a banking division, I think that the product types are so different that they would keep them separated. So even though, like you're mentioning, right, I take stats class, you take a stats class, it's the same class, but we're going to work in different industries.
Yeah, absolutely the same classes.
Yeah, I think they'll remain separate just because the focus and specialization is so different. So similar, but so different at the same time.
yeah, that's true. That's true. I understand that. But yeah, so they won't merge, in your opinion. But do you think like a quant can be an actuary as well, and an actuary can be a quant, even just as we have pointed out just a few minutes ago?
Yeah, I think it's not too hard to switch from one side to the other side.
Okay.
As long as you acknowledge, like, looking for like your first job will be challenging if you have a very specific degree. But the key to this, so if you say I got an actuarial science degree and I wanted to move to quant, the key is just listing out those commonality of skills. So when someone hiring looks at the resume, they're like, this guy's the exact same as this other guy. And so the degree doesn't matter. And I'm sure it's probably the same in actuarial sciences. Like, if I had a quant degree and I could list everything out and said, hey, I would love to work in insurance, and this is why. And then I showed the skills, I think it would be like, okay, well, right, we need these actuaries. They're in high demand. So
yeah. Do you know why? I mean, in my opinion, do you know why I think that actuary that was talking with you say that they are all what a quant is plus something else?
Yeah.
I think in my personal opinion, he said that because for being a quant, you just need a quant degree. right? You can be a physicist, you can be an engineer, an electrical engineer, whatever you want. You just need to have those crucial things, just those crucial skills, like programming. You have to know at least statistics. Just programming and stats are the most important one.
Mm-hmm.
And yeah, you can just learn many other things by your own. And if you hold an actuarial degree, I mean, you have stats, you have programming, you have even basic quant finance. You have, I mean, the Black-Scholes I also covered, the Cox, Ingersoll, and Ross models, the VAR, all those things I know. But if you are a quant and you want to go into actuarial science, people are going to ask you, did you study long and short-term actuarial mathematics? And you are going to answer, no, I didn't never study them.
Yeah.
And I can say that because I've got 2 interviews.
Okay.
One for a quant position, as I said before, and this one for actuary. And for the quant position, in my resume, I just pointed out that I knew R, I knew Python, I covered machine learning as master thesis, I covered stats. And they actually wanted me. Like, they had a lot of engineering and people from mathematics, and they said, yeah, but you are my favorite. You have all those time series and those things, and we want you. And they didn't even know that I came from actuarial science, actually, because I just pointed out I had a financial engineering degree,
Mm-hmm.
without saying what was my specialization, and I just pointed out which were my skills, my favorite skills. For the actuary job, in the interview, they were asking me a lot of specific actuarial questions. Do you know how to calculate this? Do you know how to do this? While for the quant job, they said just, okay, I'm not gonna ask you technical questions that you even know better than me. That
Mm-hmm.
was the interview. So that's maybe that's the reason, because just behind of your actuary friend, and I don't know if it's your friend, just I think just they are gonna ask you specific stuff. While for the quant profession, they will never ask you about, do you know how pricing with the Black-Scholes? I don't think that.
So it'll vary country to country and firm to firm. So even in different firms. So I interviewed at ICE, which is Intercontinental Exchange, which runs the New York Stock Exchange and all those, for a sell side derivative pricing position.
Hmm.
And they'll ask you like very specifics, like
The Black-Scholes.
No, they'll ask you like, for example, if you have a long American option and interest rates go up, what happens to the price of the option?
Okay.
So you'd have to know enough to do it.
Yeah, you still have to.
But
you need to have the background.
Yeah, but I think it varies a lot, because some firms are looking, as you're pointing out, right? They want someone with these general skill sets. They want someone just creative. You just need some math, some stats, some computer science. I think one thing that sets actuaries apart is all the exams. Because I think you have the exams in Italy too, don't you? Where you have to take all these different exams to get to specific levels in actuarial sciences.
Oh, okay.
Like your certification.
Okay. That's a little bit different between Europe and United States.
Okay.
Okay. Let's start with this. In Europe, we have the United Kingdom, which works exactly the same as United States work. Okay. So you have like the Institute and Faculty of Actuaries in United Kingdom, and you have the Society of Actuaries in United States.
Yeah.
So after your bachelor's degree, you can hold even a degree in philosophy.
Yeah.
And you become an actuary. I don't know how, but you become an actuary even with a philosophy degree. And then you have to go into all those exams until you get fully qualified. For the rest of Europe, it's different. You don't have all those exams from a professional body.
Okay.
You actually we have a Solvency II regulation. I don't know if you ever heard about it.
No.
Okay. It's the regulation for insurance companies.
Okay.
And basically, what you need to have as an actuary is just the skills. Okay, but in order to have those skills, you must hold a master's in actuarial science. You
Okay.
hold a master's, I don't know, in statistics without actuarial concentration. You cannot be an actuary. You cannot be an actuary. You must hold a master's in actuarial science. Nobody's gonna hire you as an actuary if you just hold a master's in data science or statistics. You must hold a master's in actuarial science. And then every European country has a professional body, and they just make you one shot last examination. And if you can pass that, you are fully qualified. But
Okay.
in order to access those examinations, which are professional examinations, you must hold a master's in actuarial science before. If you
Okay.
don't hold a master's in actuarial science, you cannot join for the professional qualification. But the good thing is I am working as an actuary now, but I'm only holding a master's in actuarial science without any certification. So I mean, it's just a different approach. An actuary here in Europe is more like a quant. It's
Yeah.
not a quant, but it works like a quant. You must hold a master's. You must hold a master's, at least, or even a PhD in actuarial science.
Okay.
So it's a little bit different approach. And yeah, I find the European approach to be a little bit better, actually. Not because of anything, but just because, you have a master's degree. It's like Quants.
Yeah.
I find that to have more sense.
Yeah. There's a core minimum you got to at least meet to be qualified to do the work.
Yeah, that's true. Here in Italy, you cannot be an actuary with a bachelor's degree. You can do whatever you want. You can even know everything. You can try to pass the professional examination, but you cannot access that examination if you don't hold a degree. It's just a requirement.
Okay. Interesting.
So yeah, it's completely different. It's a different approach completely. Yeah. Can I ask you something?
Yeah, go for it.
Yeah, I have a couple of questions for you. Starting with, if you could go back, just what path would you choose? What bachelor's would you go for? Would you go still for economics, or would you choose something else? And why? Why is always my questions. Why?
Yeah. So this is the hardest question I've been asked, and I've debated on making a video, and I've never made one because it's such a hard decision. I think so.
Here's your opportunity.
Yeah. So I don't know if I would change anything. Oh, man, it's hard to say that, but I don't know if I would change anything going from a finance degree into quant finance, which was like a terrible decision. I don't recommend to anybody because as you pointed out, right, going from like business, finance, and economics to like, quant finance is such a large leap.
Yeah.
One of my
you should hold a stats degree.
Yeah. One of my common thoughts would be, so going to computer science, but if I got a computer science undergrad, I don't think I would ever go into quant finance.
Yeah.
Because I like to program so much, and I was programming, back in high school. So I started programming when I was like 16 years old, and I liked it, but I never thought about getting a career in it. And then I just happened to fall into finance, and then I realized I didn't want to do traditional finance. Then I went to quant finance. But on a practical level, I think the best degree would have been to get a statistics undergrad, because I would have learned so much statistics at such a rudimentary level at the basics that when you hit a master's level, either in quantitative finance, or even if I went back, I'd consider getting like a PhD in statistics, just because you can do so much more because you have so much groundwork done in your undergrad. And then when you go to a PhD, it would have taken me I don't know, a lot further.
Yeah, true. Yeah. And now talking about, let's say, so educational stuff, would you change something about the actual Quant master's degrees, like all topics like the Cox-Ross and Rubinstein stuff, or Cox-Ingersoll-Ross, all those models, which you probably do like 40 hours of lessons on the Cox-Ross and Rubinstein, and then you don't cover at all like modern stuff like machine learning or programming, which are very crucial to the quant profession nowadays. So would you change something? Would you leave like this? What do you think about it?
Okay, so I'll go over a little bit what current programs are doing. So current masters are focusing on data science and machine learning in the US. So if you go look at like, I don't know, Columbia, NYU, Carnegie Mellon, those ones, a lot of them have data science and machine learning in the programs.
Okay.
But there's a caveat with this. You only have like a year to a year and a half for many masters, and I think everyone should have at least 2 years more time in school.
Yeah.
But even that, it's not enough to cover everything.
True.
And I like that they cover some of the traditional quant finance models for a variety of reasons. So some of them aren't used as much, but I think historically it's important to build from like first principles of understanding, like we know math and stats, and then how we slowly built up to where we're at. The other concern I have is that, there's probably less than, I would say, 5 programs in the US that actually creates financial engineers. So designating the differences here. So quant finance is like the big umbrella of all quantitative math stats in the finance realm. And then financial engineers being those who actually engineer and create derivative products. And the reason for it, I think, is that like we mentioned before, right? Stochastic calculus is such a fundamental component to like the Black-Scholes and driving the Black-Scholes.
Exactly.
But I think real financial engineering programs take this path of structure where you learn the Black-Scholes as your first class, and you go through all the simple math, Ito's lemma, Feynman CAC, and all that. You can derive it different ways, coming from capital asset pricing model, and you can come from a stats or a math perspective. But then once you learn that, then I think the program does a good job at saying, okay, this model we just learned, it sucks. It's terrible. The Black-Scholes is the worst model you've ever seen. And then they should go through all the different issues. Like, how do you fix the assumptions behind interest rates? How do you fix volatility? Because volatility is not constant. And I think when they go through all of these, you start learning like computational finance and numerical methods, because you have to do something creative where there's no closed form solution. And then I think they should wrap up the entire program at the very end with coming back to the Black-Scholes was terrible, but it was so much easier and so amazing that you can take all this complexity that we actually have in the real world and compact it down to a Black-Scholes simple equation. But I think in those sorts of degrees, it's beneficial to cover everything because you cover so many new methods. And this is where I could see them kind of stuffing in like machine learning methodology, because there are other ways to do it. And one of my gripes and complaints is I hear all these data scientists say, I can do the Black-Scholes with the machine learning model and I can do it within seconds. And I'm like, you realize I could do it with a non-parametric model, and we were doing this 20 years ago, 30 years ago, and it does the same thing and it's just as fast.
Yeah.
And it's hard to explain the difference. I think it comes down to the usage of the model. So if you just need to price an option quickly to see about what it's worth, use machine learning. It's super fast, right? There's no reason to say, let me teach you a whole stochastic calculus course and go through all these processes to do it.
Exactly.
But I think if you're going to be the one actually engineering derivative products, especially like exotic products that don't fit that model, then it's more beneficial to teach stochastic calculus. But I think data science, machine learning are becoming more critical and more crucial for quants because we're seeing more research on it. And so I think degrees need to start specializing in saying, like, I'm a financial engineering degree, and we're going to teach financial engineering specifically, or I'm going to teach something more along the lines of general quantitative finance. So trying to cover everything under the sun. Or you could specialize in something else, for example, like, I don't know, credit risk modeling, and then focus very, very narrowly on credit risk products or market risk products, for example. But I think they need to specialize on that. And then the controversial statement, which everybody wants me to say, which is, where does data science fit into quant careers? I don't think data science is a career, to be honest with you. I think it's the equivalent of me saying I am the world's greatest OLS modeler. Like, you have one tool, like
Yeah.
you have linear regression.
Yeah, exactly. I was about to say linear regression.
Yeah.
You anticipated me.
But I think that it's hard to explain to people that in data science, because they don't have a strong math and stats background typically. And I view data science as, realistically, it's a subsidiary of statistics. Because when you start breaking down all their methods, right, you start thinking about, okay, what is a neural network? Well, it's a bunch of like logistic regressions or ReLUs all put together. So you go, okay, well, great. So where does logistic regression come from? And you're like, comes from statistics. So you're like, okay, that's fine. And then you start thinking about things. So this is something that shocked me before I even knew data science. The way I fit time series models is I fit the model, I get it to work well, and then I go, okay, the residuals are not white noise. There's something missing. And then I take the residuals and I run a correlation analysis on every other variable to see what we can fit in the model to make it work. This is basically like gradient boosting. So I've been gradient boosting before I knew what gradient boosting was. It's just like a stats concept.
You're a genius. You have invented stuff.
And so I think if you look at the history of data science as well, it's computer scientists trying to figure out how to do statistics.
Basically, yeah.
Yeah, and I think they have really amazing things, though. I think that's where it's hard to balance it. Like, it's just statistics, but they have models that can do things that we can't do in statistics. So
exactly.
Natural language processing and image recognition, you can't do it with the stats model.
Yeah.
There's no way to do it.
Yeah. You need a neural network.
Yeah.
You just need a neural network. I'm so sorry for you, but you need a neural network. Yeah, I mean, computational tools are very crucial to stats now.
Yeah.
I mean, even before, if you had such a computer power, you can just process a lot of data. You can just do, even with traditional stats, if you have a computer, you can do stuff. If you have a paper and a pen, what are you supposed to do?
Yeah.
I mean, I can calculate the correlation if you give me a 10 observation data set. What else can I do, right? So computers are very crucial, and that's how you did say it's just computer scientists trying to do stats.
Yeah, and I think the quant finance is like the perfect example. You look back at when the Black-Scholes actually came out. Like, not everybody had a computer at their house.
And it comes out from the binomial model, basically.
Yeah. And so, but you start thinking about, like, if no one has a computer at their house, what do you need to calculate this complex calculation? You need something simple you can do on paper.
Yeah, binomial distribution.
Yeah,
and that's it.
Yeah, and then
it's terrible. Yeah. It's terrible, but you do that.
But then you realize, once like the history of computers has advanced, even the Black-Scholes has become extremely complex, and now we can do even like Monte Carlo simulation, which there was no way you were going to do Monte Carlo simulation back in like even like the 80s or the 90s, because computers were just so slow and so terrible. I mean, my cell phone is 10 times faster than a computer from the 80s, but
exactly. And I mean, simulation it's a super powerful tool now.
Yeah.
I mean, just imagine the one who invented the bootstrap method. I don't know who is that genius, but you couldn't do bootstrap before because you didn't have a computer. Right. You couldn't do simulation, right? But the bootstrap is just solving a lot of problems. Even in actuarial science, you use bootstrap just for studying the distribution behind, I don't know, so many things you are using for pricing products.
Right.
And if you don't have a computer, how are you supposed to bootstrap? I can just build
get a hat with a bunch of numbers
by hand. Yeah, exactly. Okay, 1, 4, and you keep going like that. And probably in 1 week, I could bootstrap.
Yeah, exactly. Right. I think this emphasizes, though, the importance of statistics and probability theory together. because I get so many people in data science and machine learning, and they say, okay, which package do I need? And they're gonna use the Bootstrap package. But I think one of the weaknesses they don't realize is, so a weakness of bootstrapping is you make the assumption that you have a robust
all the observation.
You have everything to pull from.
Yeah.
And yet when you see a lot of data scientists and machine learning people, they don't understand that intuitively. They go, but I have a historic data set and I'm bootstrapping. And in finance, this is nowhere near reality. It's extremely dangerous. And especially in a time series, you might have, I don't know, 30 data points or 100 data points.
You're assuming like the most extreme observations you already have in your data set. But it's probably not like that.
And I think that's the criticism of many with finance, is that we always like to assume normal distributions.
Yeah, that's very bad as well.
It's so easy to do math with it. I think that's the reality. But I think that's why you need statistics. It's like that big parent shell, and even probability theory ties all into this. That data science is going to be coming from that, and as long as you understand those core stats principles, you know, like, okay, this is a weakness of this method or that method.
Yeah, exactly.
And then we can use it appropriately.
Yeah, if you're a data scientist and you're just looking for the package, okay, I need a bootstrap. Okay. Are you sure this is the one thing you need now?
Yeah.
Are you sure it's gonna work? Yeah, the computer does for me. Does the job for me. Okay, if you're sure.
Yeah, I think that's a big struggle, I think, everywhere. Even in quant finance, I see a lot of people start ignoring the theory behind things, and they get really excited to apply some method. And I'm like, I get it. It's really accurate. And that's a lot of the drive in machine learning. But even in stats and quant finance, we're trying to find some correlation. But I think often, even when I say, you know, correlation doesn't equal causation, people are still excited to be like, but it has a really good fit. And I'm like,
I know, but it's not like that.
Yeah.
Yeah, correlation is not causation is a problem that almost everyone struggles to understand.
Yeah, it's in the United States, they teach an example, and I don't know why people forget it. But in most stats classes, even like the business ones, they start talking about, you know, correlation isn't causation. And they indicate the difference between murder rates and ice cream sales.
Yeah, I had the same example even here.
Yeah, and I think it's the best example, but I think everybody forgets it, and they stop to realize there's always something in the middle maybe that causes the two, which is the temperature on why it's so hot. So people eat more ice cream and then they're irritated, so they kill more people. But I think we often forget that. And I even have practitioners that come to me and say, Dimitri, it's all economics. They're all economic variables. They're all related. We can regress anything on anything else. And I'm like, no, like, you can't.
Sure.
And we see crazy stuff. Like I see, like, what is the year-over-year growth rate of like the 30-year interest rate? So it's a rate of a rate. And then they run that into some regression to predict, like, I don't know, probability of default. And so when I ask them, I go, what is a year-over-year growth rate of a 30-year interest rate? What does the rate of the rate mean? I mean, now we got to start getting into physics with, like, you know, velocity and these sorts of things. And then I'm like, so what does that mean for, you know, probability of default with unemployment? And then they go, well, it's related. It's fine. And I'm just like, I can't explain it, and I'm looking at the data, so I don't know how you're going to explain it, you know, not having that background, but
yeah,
it's shocking.
A lot of fun to see those people. Yeah, they are so funny.
Unfortunately, they're more common than I think people acknowledge. I think a lot of people assume that, like, you go and you get like an actuary degree or you get like a quant degree. And then they assume that, like, you'll get in the industry and everyone will be like geniuses that are super smart.
No.
But the longer you work, you start to realize, like, one, you have to work with people that are not quants, which is part of it. And then the other part is many quants just got the degrees and then they're not really interested in the topic. They're just wanting to do like the bare minimum, easiest path. And so instead of looking for like a complex solution to a complex problem, they just find a simple solution that makes no sense.
They just work for the salary.
Yeah,
basically. And they don't care about the job. I mean, as an actuary, I can say the same right now, but I mean, actuarial science is also not so interesting as maybe quant finance. Probably I find quant finance to be a little bit more interesting. And
Okay.
so that's why at the moment I'm just working for the salary, just to make a little bit of experience. But yeah, I can understand them. I think like 99% of people is working for the salary around here. I mean, if you don't have the salary, how are you supposed to eat?
Yeah,
But
it's the same here. I think it's part of this whole podcast season is you'll see as episodes come out. But I think even if it's interesting, people get into the groove of like, I only model these sorts of projects. So even though quant finance is like this vast area, you get narrowed into like one area. Like I'm working in credit risk. And so it's like you see like the same kind of models and the same kind of variables. And then people start thinking like, why am I going to spend 80 hours a week at work when I'm only required to be there for 40?
Yeah, true.
So I might as well, spend time with my family or go on vacation or have a hobby or those sorts of things.
Yeah.
So I think it's a natural state, but I think it's a challenging thing to kind of overcome.
Yeah, I'm also required, for example, to work like 40 hours per week. But in actual fact, I just work like 1 or 2 hours more per day.
Yeah.
It's just you have to do the job. They don't care. You maybe do all the job in 4 hours and you just say bye-bye. The important thing is that you have the job done, but you have to do it well. And sometimes it takes longer time. So you cannot just quit because you are just required to work 40 hours. I mean, at least if you want to do things well, you cannot just think, okay, it's 6 p.m., bye-bye.
Yeah,
Right?
I'm done.
Yeah, exactly. For example, yesterday I've worked until the 8 p.m. So just 2 hours more.
Yeah.
It's like you have to do your job well. And people who just only works for the salary are not supposed to do the job properly.
Yeah, I'd agree with that.
I think, yeah. I mean, you have at least to like a little bit. I'm not saying I'm just in love with actuarial science, but also at least I like it a little bit. It's still a technical stuff. It's still just stimulating my stats and my maths skills. So at least I'm enjoying it somehow and I do it. But if I was like, I don't know, a nurse, 6 p.m., bye-bye.
Yeah.
So, I mean, I can't do the job. I can't do the job. So at least you have to choose something you like.
Yeah.
You have to choose something you like.
Do you want to wrap up this podcast here with the conversation around what back office quants actually do?
Yeah, what they actually do. I mean, I have an idea because I am working with back office quants at the moment. We have a risk management project for the government, but yeah, I'm not in team with them, so I have no clear understanding. I know you are doing a lot of maths, a lot of stats, programming, and so on and so forth. I know you are trying to manage risk, but I don't actually know how does it work. What does it take? What are the main tasks? What's the core business of your job, basically?
Okay. So I'll debunk a lot of things and I'll make a lot of people mad in the process, which I'm pretty good at. So first off, I think back office, front office used to be a term, and I don't know. I don't view it as a term anymore. And I think the reason being is the way the industry has changed. So back in the day, quant used to be, I think, more of one job where it's like you could be a trader that was building strategies and models. And now, as we're like becoming more advanced and the industry is kind of maturing, we're realizing traders think really fast, quants think really slow. And so it's better to separate the two. And so now people still consider traders as front office and then quant research or model development or validation as back office. But I would argue if you look at a lot of the big firms, you don't need a quant degree to do front office anymore. So they'll typically have like a finance degree from like Princeton or something. So I differentiate them. A lot of people don't. They think they're the same thing. They say, I want to be a quant trader. I'm like, so I give you a tool that I built, and then you run the tool and you make decisions. Like,
yeah. Another question was, do traders do what quants say? Like the quant is saying you do that, and the trader does?
No.
Or it's completely different?
No. So on the trading side, typically, it varies firm to firm, but typically a quant has some sort of strategy they kind of generate. Like, I don't know, let's say there's stats arbitrage, and I don't know, say two distributions between two different assets are almost the exact same, but one typically lags the other one. So you would take advantage of the lag within that. They generate like the model for it, like the actual theory into like a model. So say you create some sort of ARIMA or Seremax model to do that, and they package the theory together and the strategy with it. And then that gets moved to what they call a quant dev, which I like to call implementation. And that's the guy that like just wants to do C++ and go home for the day. He doesn't want to waste time doing, Python and statistical assumptions and theories. And he optimizes it so that it runs extremely fast. And they typically will build it into like some sort of dashboard. So it's really easy for the trader to use. And then when you have the trader at the very end, they have the dashboard and they have the prices coming up. And if it's fully automated, they monitor it. So that model is running, but it needed a quant to build the theory and then someone to implement it. And then you need a trader to monitor it to make sure it's working correctly. If it's not, then they have to make the fast decision on this was the quant's theory, but it's not working. And so then they stop the trading. Or they can say it works well and we're going to keep going. Or they might say it works, but not the way you intended it. So they might make some sort of adjustment and make different decisions off of it. So that's kind of on the trading side, which I guess you'd call buy side. The sell side, though, where I work is just all the banking aspects of it. So I'll explain models. There are models that pool loans. So a lot of banks will generate a lot of loans, whether it's mortgages or auto loans or personal loans or student loans. And then we don't want to hold all these assets on our books because now I have all of my money given out to everybody. I can't do anything with it. So typically banks will start trading assets between other institutions, whether it be hedge funds or if it's other banks. And so banks will specialize in different products. And so even you have credit ratings. So some banks specialize in prime, which is really good customers. Some focus in subprime, which is typically like poorer customers have bad credit. And so you'll pool them all up, and then you have to create an asset out of that. So the securitization of those assets, and then they sell them. Well, they have to have models to price that. So you'll have for loans, you'll have probability of default, and then they calculate it out for the entire portfolio. And there's even things called clawbacks, which is if a percentage of that portfolio, like say more than 10% of the portfolio does not perform as you said it was going to perform, like too many people default, then we have to pay them money back, which is a clawback saying it didn't perform as we expected. So for back office, we build statistical models to do everything under the sun. So risk is just a term they use for quants at banks now. A lot of our job is, I guess it's risk related, but I wouldn't say it's like focused on risk. So some of the models I work with on the credit side are pricing and origination models. So how do we price a loan, which is what interest rate we give to different consumers. Then there's origination models, which is a consumer even eligible for the loan? And trying to understand how this works is kind of interesting. So we build a model similar to the trading example. We build a model, and then it goes to a validation team who looks at it, which is what I do, I'm validation. We check all the assumptions behind the model to make sure that it meets them. And then we go back and I look for other things, like maybe you missed a variable that's very predictive. Maybe you have something in the model that doesn't meet legal requirements, so you can't use it for some reason. And we review everything as a second line of defense and check there. And then that gets implemented into a platform by an implementation or quant dev team. And then operations research, which is another degree similar to quant finance, they actually make all the strategic decisions. So they will say, you built a model that scores all of our consumers on, say, a scale of, 0 to 1,000. And they will look at it and say, okay, a low score is a risky person, a high score is a not risky person. And they'll pick some cutoff, say like, 250 as the score. So anybody less than 250, we think it's too risky for us to make a loan to. And then anybody 250 or greater, they make a loan to. And then they're constantly doing analytics, which is different than statistics. They're just looking at numbers and charts and looking at business theory and then coming up with a way to cut it. And so that's like an example of it, but we can build models from pricing loans, originating loans, operational models. So let's say you make an auto loan and somebody doesn't make their payments, and I have a bunch of these cars that no one's making payments on. I have to figure out whose car do I repossess first, second, third, fourth. And it's based on typically like what's the likelihood I can find that car.
Yeah.
So we build models for that usage. And then you have market risk, which I've worked a little bit at. They have models that price out like derivative pricing. So if we're going to sell derivative products to somebody, stock prices for portfolio allocations. I'm trying to think what else we do. Basically, we build statistical models for anything the bank could ever use. But typically, career-wise, you get divided into categories. So I used to work in the regulatory side. So we would build all these models for CCAR, which is how much capital we need to hold for regulations. They're all time series models. And then I worked in operational risk when I was a consultant. So we specialize only on like, what's the probability we're going to get sued by somebody? What's the probability an employee makes a mistake and it costs us money? And there's, so again, sparse data, trying to model these things is challenging. And then I've worked in credit risk, which is all these loan products that we have. And so I think a lot of people understand the market risk side, right? How many stocks and bonds do you buy for a portfolio? What is the value at risk? And we do that, but then there's a whole spectrum of other models we develop.
Yeah. So it's basically not only all about the VAR.
Yeah.
Being a quant, it's not just only about the VAR.
Yeah. And this is, I guess that's my gripe and complaint, which is hard to explain to people because, so the actuary exams in the US have a quantitative finance section.
Yeah.
But it's very narrowed on like value at risk and like market risk concepts. And sometimes it will cover a little bit of credit risk, but it like I said, it's so hard. You don't have enough time in a master's degree to do all of, you can do all the core, but then you need to do, like you said, right, the 4 classes in actuarial sciences, but then you need to do the 4 classes on quant stuff.
Yeah, you need at least 3 years, in my opinion. 3 years master's degree.
Yeah.
That would be perfect. So one more year, just fully concentrated in quant finance, basically, and risk management. You need that. If you want like let's say, a very solid and well-rounded master's degree. Yeah. In Europe, we have like 2 years master's degree.
Okay.
So master's degree are only 2 years here in Europe. So but we have 3 years bachelor's.
Okay. So I hate the US's master's programs. I'll call them I don't know, I guess just quant programs. If you get a master's in anything that's a real education, I hate to say that, but like a hard science, if you get like a biology master's or a kinesiology master's or a math master's, they're all 2 years for the most part. But now people are like, hey, I want your money and I want to give you a degree, but I want your money. So I'm going to make it even better for you. I'm going to teach you in 1 year. And then it's even cheaper. And so then they shorten it. And then I'm like, I get it. It's a marketing tactic. But then for me, it's like, I'd rather hire someone with a 2-year master's because you can't squeeze in 2 years in a year. Like,
yeah, exactly. I mean, even if it's full time, we have just 2 years full time masters, and we cannot cover everything.
Yeah.
So even in 2 years full time, you need 3 years full time. I don't know if master's degrees are full time or just part time in United States, but I mean, 1 year is just you can just cover the background. The only thing you can cover is the background. One year master's in actuarial science means that you do mathematics, probability, you do probably, I don't know, econometrics, and then you don't do actuarial mathematics.
Yeah, you never cover the topic.
What kind of actuary are you? Right? So yeah, I think 3 years masters would be just perfect. But yeah, with the 2 years, you start working 1 year before.
Yeah.
But you never learn a lot of things.
Yeah.
So you have to do by yourself.
Even now at 7 years into working in quant finance, I have an infinite number of topics I want to cover. I just don't have the time.
Yeah, the same for me. I was just studying by myself a lot of stats after my master's degree, but now I started working and I basically have no time anymore. Yeah, and it's frustrating because
Yeah.
once you fall in love with one subject, and I fell in love with statistics personally, you just want to learn and learn and learn and keep going. But when you have no time, no energies, it's like, man, I want to know those things. I know that I am missing a lot of stuff and I just don't know them. And it's frustrating because you know that you don't know stuff.
Yeah.
It's so bad.
I try to explain to students, the higher the degree you get, so if you get a master's or a PhD or two PhDs or three PhDs, the more you get, I always feel like I'm even dumber than I was, because I start to realize
Yeah,
there's so much more to cover. And that's why I laughed when we talked about statistics and probability being, probabilities in the math department and stats in the stats department. Because the more stats you learn, then you realize, like, I'm missing a lot of probability that I
true.
need to support my stats. And so now you're like trying to cover all these topics. And
Yeah, probability is probably the most important topic if you want to go into stats.
yeah.
I mean, in my opinion, you cannot do stats if you don't have a probability background.
Right.
Just probability is like a prerequisite. I don't know if the pronunciation is
Yeah.
correct, but yeah, you got me. Probability is just, I mean, knowing probability is just knowing calculus or linear algebra. You cannot just miss them. If you don't know
Yeah. It's
probability,
a fundamental proof. If you don't have it,
yeah,
you can't even move forward.
you got me. Like, how are you supposed to do statistical inference if you don't know stats? If you don't know probability, sorry.
Yeah.
I mean, how are you supposed to come back to the underlying distribution if you don't know what a distribution is,
Yeah.
basically?
Yeah.
Right?
And what the sample space is.
Yeah, exactly. What's a sample space? You have a sample, but you don't know what's
Yeah.
a sample space, right? Or even Bayesian statistics. How are you supposed to cover that if you don't know what the Bayes theorem is? Like,
Yeah. Yeah.
it, it, probability is so crucial. Probability is so crucial. How are you supposed to do stochastic processes if you don't have statistics? If you don't have probability, sorry.
Yeah. Yeah. I completely agree with you. It's such a fundamental piece, but I think it's one that's often skipped.
Yeah, it's probably the piece gluing everything.
Yeah.
It's the one piece gluing everything, basically. Yeah, probability is, and in my opinion, is even the most fascinating one. I mean, it's one of my personal just subjects which I really love doing. But once you have covered probability, what else could you cover? Just statistics.
Yeah.
And yeah, now I'm realizing I'm even lacking a lot, even in stats, because you don't have time. There's so much stuff to know. There are tons and tons of books that you could read. I have so many PDF books on my computer, on just one book just for Monte Carlo simulation, one book only for the bootstrapping, one book only for regression analysis, but I just don't have time. It's
Yeah.
like,
It, and the
man, it's
older you
frustrating.
get, the less time you have. Once you start
Yeah,
having like a family and kids and all this, now you're like,
yeah,
I don't have time to sleep and eat anymore. I've got to figure out what I'm going to do.
yeah. Just sleeping is priority. I think you should have like 48 hours a day, so you can do everything.
Yeah.
You can even sleep. I mean, no, sorry, 48 hours per day to do everything except sleeping. If you want to sleep, you need like 56 hours. Okay. It's like that. Basically.
Yeah. Okay. So,
So
any final advice here before we wrap up to students out there that are
yeah,
I guess, contemplating careers in quant finance, actuarial sciences, those sorts of things?
yeah. My advice is basically the most simple one, is the advice that everyone is gonna give you, is just do whatever you like more. And the most important thing, yeah, I've chosen actuarial science because of the employment rate, because of the salary. And yeah, uh, I will say it's important to just choose something which you're gonna be safe with. I mean, you cannot just study philosophy, and then what are you going to do, right? Who needs something with a philosophy degree? I just don't need you, right? You don't give me any value.
Yeah, it's going to be a pure academic degree.
Yeah, exactly. So my advice is, yeah, you should consider something which gives you some future, like engineering, whatever you want, even biology. So you have to be sure that you are gonna have a job, but don't choose a degree just because you are cool or because of the salary. Because yeah, going back, I'm probably going to do actuarial science still, because I mean, if I do physics, I'm probably still going into finance. So what's the point? But just do whatever you like. I mean, if I could go back, I would probably switch to quant finance. I found stochastic calculus to be a little bit more interesting, or even just statistics, a pure statistics masters, which I found to be like a passion of mine. And then I probably go into finance still, but just do whatever you enjoy. Just don't do that for the salary, just only for. And I see a lot of people just right now, the quant profession is starting to go fashion, even here in Italy.
Yeah.
People are starting to know what a quant is. And I see a lot of people just, why are you going to do quant finance? Because it's cool, and I think I am smarter than everyone else, and I'm going to earn a lot of money. A lot of people just go into quant finance because of the salary. I see that. I don't really like the idea. I mean, if you are good at something, you are gonna have your good salary anyway.
Mm-hmm.
So, I mean, then if you want to go around with your Ferrari, yeah, then just go with Quant Finance if you need a lot of money. But just, I think the priority in my life is just to be happy. And if I want to be happy, I just need to do whatever I like.
Right.
Just not going for the money. The money is not gonna give you happiness. And I mean, even if I earn a little bit less than a quant, but I'm doing whatever I enjoy, and I can still pay my house, pay for my kids, and I don't have those problems, what's the point to be a billionaire, right?
Yeah.
I just want to be happy, and I don't want to just arrive to my old age and just look back and think, what did I do, right? Why did I choose Actuary, or did I choose to be a quant? If I was just sad all my life, I just did that for the salary. So uh, just pay attention and be sure you are choosing quant finance because you are enjoying stats and finance, not because of the salary. That's my advice. And I'm talking about quant finance specifically because I know your channel is just specific for quants, but as an actuary as well, if you want to be an actuary, just be sure you are going into actuarial science because you enjoy actuarial science. And then, yeah, of course, you have to be sure you are going to have some future.
Right.
If I like philosophy, I would probably study by myself, but choosing something that gives me some future. But yeah, basically, do whatever you like and what makes you happy. That's my advice.
All right. That's great advice.
Yeah, thank you.
Thanks for coming on the channel.
I'm so wise. Thanks to you.
Yeah. All right. Thanks for coming on.
Yeah, thanks for having me.